Okay, great. Okay, well, let's get busy. Let's see if I can get this thing running. Oh. Okay, well, what's driving me to do this moonshot? Well, first of all, everybody knows we haven't had a highway bill in a long time, and the infrastructure is, in fact, decaying. We also have a garbage disposal problem. Although we recycle a decent amount of material these days, we still generate so much garbage that goes into landfill. And there's noticeable problems that are created by each. Aside from, one, safety, the space, where are we going to put all this trash in the future? And of course, with the decaying infrastructure, being able to get around safely can be an issue. On top of that, the population has made it to 7 million now. Roughly 10% of that 7 billion. 10% of that 7 billion doesn't have a place to live. So roughly twice the population of the United States doesn't have a home. And the countries that are modernizing, they're looking to do the same thing we did. They see it as their turn to modernize their society. Problem is they're not using sustainable technologies to do that. And that's going to affect us all, especially when you think of the rapid growth that China has made, the fact that they have such a large number of people in that country. They've gone from maybe 10 years ago accounting to maybe 20% of the concrete that's made in the world to basically accounting for half of all the concrete that's made, which, by the way, is probably going to hit close to 4 billion tons this year. So one of the problems is there's a lot of nations that don't have the luxury of building infrastructure. They don't have a place to dump their garbage. They don't have a way of having access to concrete. And if they did, they might not have water to be able to even cure it. So with all these limitations in resources in many parts of the world, that is another issue that we have to deal with if people want to live a higher quality of life. And when you think about it, the world's not going to be able to sustain this. There just simply isn't enough material available to sustain every country that wants to live like the United States. In fact, if you run the numbers, the world cannot live like the United States. It's impossible. So this is what might happen at some point. The world may get hot enough that quite a few parts of the world will actually be unlivable. And they'll either be underwater or they won't have any water. For example, California lost enough water that you could actually coat the remainder of the United States with 3 inches of water once you get on the other side of the Rockies. That is an enormous amount of water. So cement and trash are part of the problem. Cement is one of these materials that you think is probably the most harmless thing in the world because all you do is add water, it cures, and you make your structure that you want. A lot of cement structures have lasted a long time. If you go see the Pantheon in Rome, it's 2,000 years old, and it looks like it was made yesterday. But the problem is that roughly 1 ton of CO2 is emitted for every ton of cement that's used. And cement is the second most widely used material next to water. There's nothing in between the two. So that means an awful lot of tons of CO2 are going up in the air. So when we hit the 4 billion mark for cement, we're going to hit the 4 billion mark for CO2. Another thing that's kind of silently ticking away are these little funny vents you see in the middle of green fields. I don't know if you noticed that going up the Jersey Turnpike or going over to Staten Island. They don't look like they're doing anything, but they are. They're releasing methane. And it turns out methane is a much more potent greenhouse gas than CO2 is. People use the multiple of 22. It's more complicated than that, but trust me, it is a much more potent absorber of the infrared radiation that causes the temperature climb. And on top of that, if CO2 gets us to this higher temperature, then we have another problem greeting us, which is that the amount of methane is going to start growing in concentration much, much faster. So just think about this whole problem as a little snowball rolling down the hill, getting up to a critical size where it can really do some damage. So we see this as part of the problem. That's one way you can look at this. But the other way you can look at this is say, hey, maybe we can turn this upside down and turn this into a solution. So what I've done is figured out how to take cement and trash and turn it into a solution instead of a problem. So the idea here is take a low emissions carbonate cement. And this is the cement that Jackie alluded to. And I'll explain to you in a little bit what that actually is. And you mix the cement with aggregate and you make concrete, okay? And that's the sand. The aggregate is the sand and the gravel. Then you use this process called trash gasification, and we make CO2 and water. And that might sound funny. What do you want to make more CO2 for? You just told me I had a big problem, right? Well, I think making CO2 is much better than making methane, and that's what the garbage dumps do. So let's stop that. While we're at it, why don't we use the gasification process to create electricity, heat, and ash? And the way that happens is the technology I'm going to show you makes what's called syngas, which is a mix of carbon monoxide and hydrogen. You mix it with air, you get a big exotherm. Turns out most diesel engines will actually run on syngas. Now, Exxon doesn't want you to know that, but you can, in fact, run a diesel engine just putting syngas through as opposed to some type of a liquid. And we have a little bit of ash left over, and the idea is take that ash that's left and put it back into the concrete. That's what we call aggregate. And so we use the water that's created from the trash to make concrete because we need to form it into a shape. But this time, the concrete hardens with CO2. We're not using a material anymore that uses water because cement wastes billions of gallons of water every year. It would be great if we could stop doing that. So why don't we take it out of our trash? Because now you can go to the most arid region of the world and you can use that trash to create the water that you need either for this cement or even potable enough to drink. So this is a machine that the Army likes to call Tiger. I didn't put any acronyms up here, but this machine can fit in my office. Now, I got to admit, I don't have a really small office, but I don't have a huge office either. This can fit in the back of a moving truck real easily and be lifted by a forklift. And this technology developed by the Army is now being commercialized by a company called Leidos. Now, this machine I just showed you was used in Afghanistan successfully to power a base with 600 soldiers who generate roughly a ton a day of garbage. And that's just the trash that the soldiers generate. Lots and lots of plastic bottles, lots of paper, and lots of liquid. You know, there's uneaten food, there's you drink it and finish, all that stuff goes in here. And this machine is able to put out syngas and power enough electricity to run an Army base with no other source of electricity. The reduction in solids is roughly 30-to-1. Like I said, what's left over we can throw into our concrete. And now we've gotten rid of the sanitation problem because we no longer have any waste. We don't have to throw it anywhere because there's nothing to throw. We conserve land and we conserve water. Now, what about that concrete? Well, here's an example of a hollow core building slab. And if you look right in the back there, this is the tiny little machine that makes this building slab. It could make a road bed if you want. It can make, like I said, a building slab. It can make a barricade that'll protect soldiers. But this is the actual concrete that I told you about that consumes CO2 and uses very little water, about 80% less water than cement, which is a really big number. So how do we do it? What's our secret? Well, we take good old limestone and react it with silica to make calcium silicate. This is one way to do it. But guess what? For those third world nations and for those people that have encountered terrible disasters that have wiped out their communities, there are soils out there that you can react directly with CO2 to make it carbonate. For example, Afghanistan is loaded with it. And if you go to Mexico, there's plenty of it there as well. And we've even taken modifications of this classic process for making cement and have managed to turn Piscataway mud into cement. We can take fly ash, all those billions of tons that are out there, and convert it. So when you take a look at this, you see that it's a very simple reaction, but there's a big difference between what we do and what the cement industry does. We halve the amount of calcium carbonate that's in there, at least twice as low a concentration, and we lower the temperature 250 degrees C. Now, by doing that, we've just cut the energy bill and the CO2 emissions by 30%. That's an amazing number. And we've proven this. We've gone out to a cement mill in the middle of Whitehall, Pennsylvania, 107-year-old cement mill, and we gave them even greater energy savings than what we promised them. And there were no capital improvements. So the cement industry actually loves this idea. And it's a good idea when you have an idea if you can get big companies to participate, because then you can do things fast. Okay? Now, I started the company called Solidia Technologies, and I always tell people, never let a professor run a company. I don't run this company. We have seasoned professionals doing this, and I get to stay in my office and have fun dreaming about things. The point is with this technology is that the cement industry already has its raw materials sourced locally in all the parts of the world that have the infrastructure. And for those that don't, there's technology that we can teach people how to do that will enable them to do it on a village level right up to a corporation level. And right now, there actually are countries that will be engaged with large cement companies that don't have a cement industry now just because of that. Now, again, it's made at a cement mill and it doesn't cost more. And we've done 2,000 tons a day, which is a really good production rate. Now, the cement itself, I like to think of it as a breathing material. You can actually hear the material respire the CO2 in when you start the curing process. And you make basically calcium carbonate and silica. It's very similar to Portland cement concrete, except that we're using CO2 instead of water. Again, local raw materials. We can go to an existing concrete plant nearby, and we can make a wide range of different materials. And that makes it very attractive to concrete manufacturers. So there's roughly 10,000 concrete businesses in the United States alone. And there's roughly 100 cement companies. So it's one of these things that we could turn around right away if we could get the government to pay attention. So best yet, it has unbelievable properties. First of all, you can make a material in less than a day. 30 minutes is our record for full strength. No shrinkage, so the material doesn't crack like a lot of cements you see. The strength can be up to 4 times stronger than a conventional, ordinary Portland cement. It's much more abrasion resistant. It doesn't deform when you have a lot of weight on it. We call that creep. It can take bad weather really bad, like today. And the thing that you've never seen before in cement, you can throw all the sodium chloride on you want, it won't decompose. Different chemistry, that's why. And you won't see all those white spots leaking out of your wall, and we can reduce the CO2 emissions by 70%. So think of that. 4 billion tons of CO2. We can drop that by 70% just by switching over to a technology that doesn't require anybody to buy new equipment. All right, switch for me. So what we really want to imagine at this point is I want you to imagine a green toolbox, one of these shipping containers where we can put all the equipment we need to get people to gasify their trash and learn how to make infrastructure materials. And imagine having the capability to ship these all over the world, along with everything else that we ship, and allow communities to build themselves from nothing, allowing established countries to be able to change the way they make things. So it's an infrastructure kit. It can go anywhere. So the impact, the numbers are really amazing. Now, I'm going to tell you right away, I assumed the best possible conditions with these numbers. But slash every one of my numbers by 10. Go ahead. They're still amazing. Okay? Enough CO2 to cover every piece of land mass on the Earth 3 feet deep. Go ahead. Cut me by 10. That's still an amazing number. Generate enough electricity to power half of the United States. Save enough energy to give every gas tank 2 fillings. Save enough water to fill Lake Erie twice, and sparing a lot more of the earth so we can grow plants, just like Clark was talking about. So I think that even, like I said, even if you slash this by 10, the numbers are really compelling, and we're getting rid of trash. We didn't even list that. So how are we going to do this? 3 steps. First of all, we want to establish the global cement supply, and we're in the process of doing that, but it costs a lot of money to be able to do something like this because nobody is going to build a road out of this material until the governments have tried making roads out of these materials. Well, the problem with the United States is they can't even pass a highway bill. So how the hell am I going to build a road? My company actually has to go to Europe to do this, or Canada. U.S. is like, closed for business. We have to get in a network of precast and cast-in-place concrete manufacturers. And that has to happen after this is done. The other thing that we have, which is a big surprise, another cool invention done at Rutgers, is what we call a kiln-free cement. We now know how to make cement without using the kiln. Now, if I went and told all my concrete friends that, cement friends rather, they're not going to be too happy because they're going to start worrying about their rotary kilns and cement plants. But we can start beginning to deploy this in countries that don't have these kinds of plants and then kind of get them into it slowly. Now, getting the trash gasified. Leidos needs to work on smaller, cheaper, more reliable, powerful, and automated machines. And you have to establish the supply chain. You just can't say, hey, go take the garbage out. And you have to be able to establish how you connect to the grid. So we need this, what we call an agile distributed grid. But now we don't have to put these big, powerful wires under the ground to generate our electricity in Alaska so we can get it in New York. And then we have to put everything together. We have to put this machine together with building the concrete, show we can make it for precast concrete, and show that we can also do it in a mobile process for putting roads in. So this is just a picture, by the way, of how we can take water pipes, which lots of countries actually need for fresh water, and make buildings. And this happens to be a restaurant made of water pipes. So we can't do anything without a team. Every one of these people are important players, but we've basically got only enough money to fill our pockets halfway. We need to fill the pocket much more heavily in order to get something done. For example, Nettle is in charge of CO2 utilization in the Department of Energy. They only get $1 million a year to do research in CO2 utilization. We need to have more like $100 million a year so people can think of more things to do with CO2 than burying it underground. We're spending close to $2 billion to figure out how to bury it underground so in 10 years from now, they can bury as much CO2 as I'll be able to do in 6 years for probably about $30 million spent. We need to have more like 100 million a year so that people can think of more things to do with CO2 than burying it underground.